For 25 years now, you have relied on this one very simple digital constant.
Right, the blank rectangular search box.
Exactly. You open a browser, you type in a few fragmented words, you hit enter, and, well, you get a list of links.
Yeah, the classic 10 blue links.
Right. But overnight, that tool, and honestly, the entire economic model of the internet behind it just fundamentally broke.
It really did.
We are witnessing the end of search as we know it.
I mean, it is a profound rupture in how we navigate the digital world. What is replacing it is a completely different architecture.
Yeah.
It's a shift from simple text retrieval to a multimodal autonomous reasoning engine. And the tricky thing is, this isn't some slow beta rollout.
Right. It's happening globally right now, which is exactly why we're dedicating this deep dive to synthesizing this landmark report.
The Great Search Engine Metamorphosis.
That's the one. Our mission today is to unpack this massive overhaul of the ubiquitous search box. But more importantly, we need to predict the long-term search trends this is going to create. We're going to break down how the underlying architecture has changed, what it means for the macroeconomy of the web, and, how your daily workflow is about to be entirely rewritten.
Because if you just view this as a user interface update, like, oh, it's a new font or a slightly bigger box, you're completely missing the forest for the trees.
Oh, totally.
The report explicitly calls this the biggest overhaul in more than 25 years. They are replacing the legacy indexing system with what they call a fast reasoning model.
Right.
And that requires a complete teardown of how we even input information in the first place.
So let's start exactly there. The physical interaction, the omni-input revolution.
It's such a massive shift.
It really is. We are moving away from typing grammatically incorrect caveman speak, like plumber near me emergency.
Right, yeah.
We're moving into an entirely new paradigm of communication. The report notes that the search box now accepts images, massive files, high-definition video.
Don't open browser tabs.
Exactly. You don't just type your problem anymore, you show it.
And the psychology of this is just fascinating. I mean, for a quarter of a century, we've been forced to strip away the rich context of our actual human problems.
We had to translate them.
Yes, into search engine speak. Because the machine could only process text strings.
Right.
Now, the interface is adapting to us. But to really understand the long-term trend here, we have to look at how the machine actually processes all that multimodal data.
Because it isn't just looking at a picture and guessing the text equivalent.
No, not at all. And this is where we have to talk about vector embeddings.
Okay, let's break that down. Because if let's say I dump a photograph of a broken sink pipe, a PDF of my house's plumbing schematic, and a text query asking, how do I fix this without shutting off the main valve?
Traditional search architecture would just completely fail there.
Exactly. It indexes text.
Yeah.
It has no idea how to cross-reference a photo with a blueprint.
Right. Because to the old system, an image is just a grid of pixels, and text is just a string of characters.
They exist in completely different universes.
Exactly. What multimodal vector embeddings do is take all of these different data types, the image, the text, the PDF, and translate them into the exact same mathematical language.
So they can finally talk to each other.
Yes. Think of it like a massive multidimensional coordinate grid.
A coordinate grid where concepts live near each other.
Precisely. So if you plot the word water on this grid and you plot a photograph of a puddle, they end up geographically very close to each other in that mathematical space.
Even though one is text and one is pixels.
Right. So when you feed the engine a photo of a broken pipe and a PDF schematic, it maps all of that data into this shared vector space.
Wow.
It actually understands the relationship between the visual shape of the pipe in your photo and the technical diagram in your PDF.
Okay, I want to use a real-world analogy to ground this for you, the listener, because the user experience shift here is just huge.
Go for it.
Imagine your physical desk. You've got a stack of tax documents, some random sticky notes, maybe a photograph of a broken car part, and a half-read book.
Feels messy.
It is. And the old way of searching was staring at that mess, writing down 3 keywords on an index card, handing it to a librarian, and just hoping they brought back a useful book.
Yeah, a lot of trial and error.
Right. But this new update, it's like scooping up everything on that physical desk, dumping it directly into the engine's lap and saying, sort this out.
And that is the exact user behavior the new interface is actively trying to encourage.
Oh, absolutely.
You can see it in the design. The report points out that the search box physically expands as you type or upload.
Right, it grows from a single line into this massive text area.
Yeah, and think about the psychology there. When a box is 40 pixels high, it subconsciously commands you to keep it brief.
Keep it to 3 words.
Exactly. But when it physically expands, it gives you psychological permission to elaborate.
I'm going to push back on that, though, because elaborating sounds like work.
Well,
I mean, I'm used to typing 3 words and hitting enter. It takes 2 seconds.
right?
The report says the box expands to help you describe exactly what you need. But does having to write a highly descriptive paragraph, upload a video, and attach a file actually make searching easier?
I see where you're going with this.
It feels like we are transferring a massive cognitive burden right back onto the user.
It definitely feels that way initially, yes. But we really have to look at the entire life cycle of a search query.
Okay.
Under the old 3-word method, sure, the front end was frictionless. You typed best restaurants nearby in 2 seconds. But what actually happened next?
Well, you get a page of 10 blue links.
And you click the first one. Oh, it's an SEO-optimized spam site. So you click the back button.
Yeah, that happens a lot.
Then you click the second one, has a hard paywall. You go back again. You realize you need a place with outdoor seating. So you refine your 3 words to 5 words.
You search again.
Exactly. The cognitive burden wasn't actually low in the old system. It was just deferred.
Ah, I see.
You spend all your mental energy sifting, sorting, and verifying the results after the search.
So the friction was backloaded. It was all trial and error.
Exactly.
Mm-hmm.
What the expanding box does is front-load the context. Yes, it takes you 30 seconds to upload the video and write out the constraints.
But the result you get back is a synthesized, highly specific answer.
Precisely. The long-term trend here is a transition from a simple command prompt to more of a collaborative workspace.
Right. You aren't just issuing commands anymore. You're establishing the parameters of a complex task.
Exactly.
But wait, if I'm dumping 20 open tabs, a massive PDF, and a video into this expanding box, the sheer volume of unstructured data I'm throwing at this thing is staggering.
It's massive.
Which brings us right to the architecture required to actually sustain this. Let's look at the benchmarks the report highlights, specifically the engine's capacity.
Right, the numbers are wild.
Their report says the system supports a 1 million token context window. That phrase gets thrown around a lot, but we really need to dissect what that actually demands computationally.
We absolutely do, because the context window is the defining bottleneck of any large language model. Think of the context window as the engine's active short-term working memory. It's literally how much information it can hold in its brain simultaneously while formulating an answer for you.
And computationally, a token is basically a fragment of a word. But what does a million of them actually look like to a user?
1 million tokens translates to roughly 750,000 words.
Wow.
To put that in perspective, that's the equivalent of 7 or 8 full-length novels.
So you aren't just giving the engine a few paragraphs, you're feeding it an entire library shelf of data.
Exactly. But here's the really critical part. Reading 1 million tokens isn't the hard part for the machine. It is the attention mechanism required to actually understand them.
Right, because it's not just reading linearly like a human does.
Yeah.
It has to know how word number 12 connects to word number 650,000.
Precisely. In these modern transformer architectures, the model uses what is called self-attention.
Okay.
It compares every single token to every other token in the context window to determine relevance and build meaning.
Oh, wow. So if you double the size of the context window?
The computational power required doesn't just double, it squares. It is a quadratic increase in memory and compute cost.
N squared problem.
Exactly. So when the report casually mentions a 1 million token context window, it's signaling a massive, massive breakthrough in infrastructure and hardware efficiency.
It means you can feed all 20 of your open browser tabs into the engine.
And it can cross-reference the mortgage rate on tab 4 with the amortization table on tab 19.
Without forgetting what was on tab 1.
And without the server melting down.
Which explains how the multimodal input is even possible. But memory is just storage. You also need the reasoning power to actually make sense of it.
Right, exactly.
The report notes this new model scores over 90% on a graduate-level science reasoning test.
Yeah.
And nearly 80% on a software engineering benchmark. Now, obviously, most users are not asking their search engine to solve quantum mechanics.
Right.
So why does a consumer search engine need graduate-level science reasoning just to help someone navigate the web?
It's a really common misconception that these benchmarks are about subject matter expertise. They aren't.
Okay, what are they about?
They are stress tests for the model's capacity to follow a complex, multi-step chain of logic.
Ah!
A graduate-level science test requires the engine to understand heavily constrained parameters, synthesize conflicting data points, and arrive at a highly specific conclusion without hallucinating.
Okay, let's define hallucinating here because it is arguably the biggest risk in this new era.
Oh, absolutely.
Huh.
A hallucination happens when the model, which is essentially just predicting the most statistically likely next word, gets lost in its own vector space.
It loses the logical thread.
Exactly. It starts generating information that sounds plausible, but is factually entirely wrong.
Right.
If you ask a basic model a highly complex question with 20 constraints, the probability of it hallucinating skyrockets because the mathematical path to the correct answer is just too narrow.
So the graduate level reasoning isn't for doing actual science.
No.
It is the architectural guardrail against hallucination when dealing with incredibly messy, constraint-heavy human queries.
Exactly. Let's look at a really mundane example. Comparison shopping for a new laptop.
Sure.
You don't just search best laptop anymore. You feed the engine your budget, your preferred operating system, the specific software you need to run, your battery life requirements.
Maybe even a PDF of your company's IT compliance standards.
Right. And to parse all those constraints, weigh the trade-off, and synthesize a singular recommendation without hallucinating a feature that doesn't exist.
That requires the exact same logical architecture as solving a high-level science problem.
It really does.
And here is the metric that ties this all together: speed.
Yeah, the speed is wild.
The report makes a point to state that this new model runs 4 times faster than its predecessor. We always expect tech to get faster, but highlighting speed right alongside a million-token context window and graduate reasoning that is deeply intentional.
It's intentional because intelligence is irrelevant if it induces latency.
Right.
The defining characteristic of a search engine is immediacy. It is an instant oracle. If you feed the engine 20 open tabs in a complex query, and it takes 3 minutes of compute time to generate that graduate-level synthesis, you aren't going to use it.
No, I'd close the tab and go back to the old way.
Exactly. So the 4x speed increase is the invisible glue holding this entire paradigm shift together.
Yeah.
It masks the staggering computational weight happening in the background.
You get the synthesis of a million tokens, parsed with the logic of a software engineer, delivered in milliseconds.
And the long-term trend we are tracking here is the frictionless, invisible application of elite reasoning to everyday, mundane tasks.
Like the user doesn't know and doesn't need to know about vector space or quadratic attention mechanism.
Right, they just know the box understands them instantly.
Okay, so we've established the underlying mechanics: multimodal input, massive context memory, advanced reasoning, and hyperspeed. But everything we've discussed so far is still, at its core, a passive transaction. You provide the data, it provides the synthesis, but the report details a capability that entirely shatters that dynamic.
Oh, the agents.
Yes. This brings us to the agentic era, the transition from passive retrieval to active delegation.
This is huge.
The text states that new search agents can monitor the web continuously, book local experiences on your behalf, and generate custom interactive apps directly inside the results page.
This is the Rubicon. This is where the search engine ceases to be a highly advanced library and becomes an autonomous personal assistant.
I want to aggressively dissect this phrase, though. Book local experiences on your behalf.
Okay.
Because historically, the internet has always required a human being to execute the final node of a transaction.
Right, the final click.
Yeah. The search engine can find the flight, it can index the hotel reviews, it can show you the prices, but the human has always had to click reserve, enter the credit card, and confirm.
Yeah.
By taking agency, the search engine is reaching out of the digital realm and executing actions in the physical world.
It is an entirely new layer of the internet stack. And to really understand how it works, we have to look at the mechanics of tool calling.
Okay, what is tool calling?
An AI model by itself is just a brain in a jar. It can generate text, but it can't actually do anything.
Right.
To book a flight, the model has to be equipped with API wrappers.
Let's break that down for the listener. How does the model actually talk to the airline?
An API, an application programming interface, is essentially a digital doorway that allows two software systems to talk to each other.
Okay.
When you ask the agentic search engine to book a flight, the model uses its reasoning capabilities to translate your natural language request like, get me to Chicago on Friday morning, into a highly structured JSON payload.
A payload?
Yeah, it formats the dates, the destination codes, and your preferences into a strict data format and fires that payload through the airline's API.
Hold on, though. This is exactly where the liability alarm bells start ringing for me.
I don't blame you.
There is a massive structural leap between an AI summarizing an article and an AI spending my actual money.
Yes, there is.
What happens if the reasoning model hallucinates?
Hmm.
What if it books a flight for a month later or books a non-refundable $1,500 ticket to the wrong city? How does the architecture handle that level of trust and security?
It is the single biggest hurdle for agentic search.
Hmm.
And the solution relies on strict sandboxing and user-in-the-loop authentication.
User in the loop. Okay.
The agent isn't given unrestricted access to your bank account. It operates within pre-authorized, tokenized environments.
Right.
When it builds the itinerary and formats the API request, it effectively pauses the autonomous process. It presents the finalized structured action to you and requires biometric or two-factor authentication to execute the final API call.
Oh, I see. So it builds the entire bridge, but it forces the human to walk across the final foot of it.
Exactly. But the heavy lifting, the cross-referencing of a dozen different booking systems, the alignment of dates, the filtering of constraints is entirely automated.
Yeah.
Let's look at the dozen open tabs workflow mentioned in the report. If you're planning a trip, you used to have a tab for flights, a tab for hotels, 3 tabs for reviews, a weather tab, maybe a spreadsheet.
Yeah, hours of context switching. It's exhausting.
But with agentic search, you just type your constraints into the expanding box. Budget, dates, dietary preferences.
Okay.
The engine's agents fire off API calls to the airlines, the hotels, and the restaurants simultaneously. It pulls all that structured data back into its million-token context window, uses its graduate-level reasoning to ensure none of the logistics conflict, and outputs a single executable itinerary.
You review it, authenticate it, and the trip is booked.
Exactly.
You know, the best way to categorize this long-term trend is that we're going to stop searching for information and we are going to start searching for outcomes.
That is exactly it. Outcomes.
I don't want information about Chicago flights. I want the outcome of a booked trip. And the report highlights another capability that reinforces this outcome trend.
The ephemeral software.
Yes. The ability to generate custom dashboards or small interactive apps directly inside the results page.
This concept of ephemeral software is technologically a marvel.
Explain how that works. How does a search engine suddenly become a software developer on the fly?
Well, when you ask a complex comparison question, say, comparing the historical financial data of 3 different tech companies, text is a terrible way to view that answer.
Right, I'd want a chart.
Exactly. And the reasoning model recognizes this. Instead of writing a paragraph, the model writes code.
Really?
Yeah, usually standardized web components like React or specialized JavaScript charting libraries. It writes the code, injects the real-time financial data it just pulled from the web via APIs into that code, compiles it in a secure sandbox directly on the search results page, and renders an interactive sliding graph.
So it builds a bespoke piece of software tailored exclusively to my exact query for an audience of 1.
Yes. And the moment you close the tab, that software ceases to exist.
Yeah.
It is entirely ephemeral. It means the search engine isn't just a directory of existing tools on the web. It is a universal tool builder. It creates the exact interface you need, the exact moment you need it, and then discards it.
When you combine all of this, the ephemeral software, the continuous web monitoring, the API tool calling, the million-token memory, you are no longer looking at a search page.
No.
You are looking at a personalized, real-time command center for your entire digital life, which naturally brings us to the hypergrowth section of the report.
The adoption rates are insane.
Because if you build a universal command center, people are going to use it.
And the scale of that adoption is staggering. The report notes that the conversational AI answer mode has already passed 1 billion monthly users.
A billion.
And usage is roughly doubling every quarter.
We really need to pause and look at what that velocity actually means for the physical infrastructure of the internet.
It's terrifying.
1 billion users is astronomical. But if it is doubling every quarter, you hit 2 billion in 3 months. 4 billion in 6 months. That is not a linear adoption curve. It is a vertical wall.
And it is a wall that breaks physical infrastructure.
Yeah.
When you transition 1 billion users from a lightweight indexing search, which requires very little compute, to a heavy, generative, reasoning-based search, the strain on global data centers is unprecedented.
Let's talk about what actually breaks during that hypergrowth. Because it's not just a matter of writing better algorithms.
No, it is a matter of atoms and physics.
Okay.
To run agentic search at that scale, you need an incredible amount of silicon.
All right.
Specifically, advanced GPUs capable of parallel processing for large language models.
Right, the chips.
And the supply chain for those chips is bottlenecked by a handful of fabrication plants globally. But even if you have the chips, you run into the power constraint. Yes. A reasoning query takes vastly more electricity than a traditional search. Data centers are literally running up against the limits of municipal power grids. The hypergrowth is pushing the physical limits of our electrical and manufacturing infrastructure.
Which makes the next prediction in the report highly suspect to me.
Which one?
The source explicitly predicts that over the next 3 to 6 months, expect competitors to respond with their own agentic search features.
Ah, right.
Okay, I am calling BS on this timeline.
Really?
Yes. We just laid out how this requires million token context architectures, complex API tool calling ecosystems, ephemeral software generation, and massive power-hungry server farms. How on earth can a rival tech company spin up a competing agentic engine in 3 to 6 months?
It is a phenomenal point for debate.
Yeah.
The 3 to 6 month window is likely a mixture of public relations spin and the reality of parallel industry development.
Okay, explain the PR spin part.
Well, the PR spin is obvious. The source company wants to frame this as an immediate arms race to keep their valuation high and their narrative dominant.
Right, they want to set the clock for the rest of the industry.
Exactly.
Yeah.
But on the other hand, the foundational research behind large language models isn't proprietary to one company.
Sure.
The white papers on attention mechanisms and vector embeddings have been public for years. Rivals haven't been sitting on their hands, they've been building in secret.
Sure, but...
However, your point about infrastructure is the critical bottleneck. A rival might have the code ready in 3 months, but securing the hundreds of thousands of GPUs and the megawatt power contracts required to deploy it to 1 billion users, that takes years, not months.
So even if it is an arms race, it's an asymmetric one defined by hardware.
Absolutely.
But regardless of whether rivals catch up in 3 months or 3 years, the standard for consumer tech has been permanently elevated.
Undeniably. Basic AI chat interfaces are being commoditized.
Right.
If a standalone tech product requires you to manually port data back and forth or doesn't offer autonomous agentic actions, it's going to feel archaic to a user who is used to a ubiquitous search box that handles everything seamlessly.
The standalone AI chat app is deeply threatened by an OS-level or browser-level search agent.
Totally.
But while the user gets this incredibly powerful command center, this exact dynamic is triggering a macroeconomic crisis for the rest of the web.
Yeah, the dark side of all this.
And this brings us to the ultimate overarching trend we have to predict today: the search engine as the final destination. All of this incredible technology, the expanding multimodal box, the massive token memory, the real-time software generation serves one singular, ruthless purpose.
Keeping the user on the search results page.
Exactly. And the report addresses this head-on. It notes that this scale raises fresh questions for publishers about where search traffic goes next.
Right.
And it predicts a continued debate over how much traffic still flows to outside websites once search itself becomes the destination. So let's unpack the history of the traffic economy to understand why this is so devastating.
For 25 years, the economic contract of the internet was built on the concept of the transit hub. The search engine was the hub. Its job was to crawl the distributed web, index the information, and map it. In exchange for indexing a creator's content, the search engine sent human traffic to that creator's website.
And traffic is currency.
Exactly. Human traffic drives ad impressions, affiliate link clicks, and subscription revenue.
The whole system runs on it.
The entire publishing industry, from massive news organizations down to the independent recipe blogger, built their business models around the reliable flow of outbound traffic from the search engine.
But the agentic era severs that contract.
It completely cuts the cord.
Let's go back to the comparison shopping example. If I am looking for the best running shoes, I used to click on a running blog's article. That blogger got my ad impression.
Right.
But now the search engine's agent reads the blog, extracts the data, cross-references it with 10 other blogs, and uses ephemeral software to build me a custom comparison slider directly on the search page.
And you get your answer instantly.
I never click the link. I never visit the blog. The blogger gets zero traffic, zero revenue.
This is the collapse of what we call the utility web.
The utility web.
Yeah. And we have to ask you, the listener, directly. Think about the last 10 websites you visited today. How many of them did you visit because you genuinely wanted the human perspective of the author? And how many did you visit simply to extract a piece of utility, a recipe, a quick tutorial, a stock price?
I would bet 80% of my browsing is pure utility. I don't care who gives me the steps to fix my router. I just need the
And
steps.
that 80% is what the reasoning engine is going to absorb entirely.
Right.
Why would you ever visit a utility site when the search box can extract the data and format it perfectly for your specific context? But this raises a catastrophic economic question.
What's the incentive?
Exactly. If the creators of that utility content are no longer compensated with traffic and ad revenue, why will they continue to publish the raw information that the AI agents rely on to function?
It's the snake eating its own tail.
It really is.
The AI needs the web's data to generate its answers. But by generating the answers on the search page, it bankrupts the people creating the data. So how does the web survive this? What is the long-term trend for the internet economy?
We are going to see a brutal bifurcation of the web.
Okay, a split.
The utility web will largely collapse into the centralized answer engines. Publishers who rely on easily synthesized information will either fold or they will be forced into direct licensing agreements with the search companies.
Where the AI companies pay wholesale for access to their data feeds.
Exactly, entirely bypassing the ad-click model.
And what about the other 20%, the experiential web?
That is where independent creators will have to retreat. The only content that survives outside the search box will be highly original, deeply human, personality-driven content.
Right, because the AI can't fake that.
No. An AI can synthesize a recipe, but it cannot synthesize the parasocial relationship you have with your favorite chef.
Yeah, that makes sense.
It can summarize a movie plot, but it can't replicate a passionate, nuanced critique from a reviewer you trust. The web will shrink, but what remains outside the search box will have to be intensely human.
That is a staggering macroeconomic shift. I mean, we started this deep dive talking about a UI update, a box that takes pictures of pipes and expands when you type, and we've followed the technical logic all the way to the potential restructuring of the entire global web economy.
It really highlights how deeply our seemingly simple digital routines are tethered to massive economic realities.
It perfectly encapsulates the title of the report, a metamorphosis. The old web isn't just getting an upgrade. The fundamental cellular structure of how information is indexed, retrieved, and monetized is dissolving and reforming into an entirely different organism.
It's a completely new world.
Okay, let's take a breath and wrap our heads around the massive journey we've just been on today.
It's been a lot.
We started by exploring the death of the simple keyword and the rise of the omni-input revolution. We broke down how vector embeddings allow the search engine to process images, PDFs, and text in the same mathematical space, requiring us to shift from typing short commands to engaging in rich, multimodal conversations.
And then we looked under the hood at the infrastructure required to support that. We examined how a 1 million token context window, despite the quadratic compute costs of the attention mechanism, allows the engine to hold vast amounts of data in its working memory.
Right.
And we discussed how applying graduate-level reasoning at 4x speed prevents hallucination and makes the parsing of complex, constraint-heavy queries completely frictionless.
Which paved the way for the agentic era. We unpacked how the engine uses API tool calling and secure sandboxing to actually take agency in the physical world.
Booking flights and making reservations.
Yes, while acting as an on-the-fly software developer to render ephemeral dashboards directly on the results page.
All of which is driving hypergrowth that strains the very physical limits of our silicon supply chains and power grids.
Setting off an intense hardware-defined arms race across the tech sector.
And we culminated with the existential crisis facing the wider web. With the search engine transitioning from a transit hub to the final destination, the utility web faces economic collapse.
Forcing a future where independent websites must pivot entirely to deeply human experiential content just to survive.
It is a profound amount of systemic change happening all at once. But by understanding the mechanics of how we got here, from the vector space to the API wrappers to the traffic economy, you are now equipped to anticipate the trends that will define the next decade of our digital lives.
I want to leave you with one final provocative thought to mull over. It builds on the idea of AI agents continuously monitoring the web on your behalf.
Okay.
Right now, you surf the web. You browse. You stumble across unexpected things. It is a defining human activity of the last 30 years.
Absolutely.
But if our AI agents are the ones continuously reading, watching, indexing, and monitoring the web 24/7, pulling only perfectly customized, synthesized answers into a single expanding box, will the next generation even know what it means to surf the web?
Oh, wow.
Or will browsing become an obsolete activity? Will the act of discovery simply be outsourced to the machine while we sit at the terminal waiting for the finalized outcome?
It is a question that challenges the future of human curiosity itself.
It really does.
Okay.
So this week, as this massive global rollout takes effect, pay close attention to your own muscle memory. The next time you open a browser and your eyes dart to the center of the screen, notice what happens when you start typing.
Yeah, watch the box.
Notice how the box reacts and think about the staggering machinery and economics operating just behind it. Because that simple rectangular bar isn't just a tool anymore. It is an entirely new way of interacting with the world. Thanks for joining us on this deep dive.